Hey, everybody. This is Astronomy Daily Live. Hope everybody is well out there. I'm right in the middle of our first. Actually, it sort of started yesterday, but today was sort of our first. At this location, monsoon storm. So that is taking place as we speak right now. So one of the characteristics of monsoon storms is that uh, quite a bit of the time, quite a bit of the time, um, the power will go out. So I would say, a pretty good chance that at some point during this live stream, power is going to go out, and that means that this live stream ends like that. So I'm going to do something right now that I usually do at the end, and that is thank everybody for coming. Um, I will say, since it's the beginning, to come on in. Um, hope that your past evening and/or day was a nice one for you. If you're new here, watching this for the first time, coming from who knows where, right? However you found this channel, this live stream, make sure to subscribe. I do this every single day at 2 hours UTC. Um, Now, I say every single day, but once in a while, something comes up, and it's like, nope, not happening today. Not happening today. And I don't sweat those things at all. I'm trying to be here every single day, and sometimes I can't, and so that's how it is, right? This is a very, very casual gathering. We're not, I'm not going to sweat uh, 1 or even 2 days, right? It's like, that's all right, no big deal. So, feel free to come in every single day if you want, and a lot of you do. Anta, hey. Uh, Bobby is here. Uncle Bill with the cool shades, cool. So, uh, anyway, so yeah, watch this every single day. Watch it every other day, every few days, every week, every month, whatever. It's you are welcome. You are welcome to come on in anytime you want, and that's sort of the cool thing about this daily uh, live stream, right? Is that uh, yeah, we can just basically chat about whatever comes to mind, and that's what uh, some interesting conversations, or at least some interesting thoughts, uh, can pop out of those kinds of conversations. So yeah, I just like to sort of follow my nose here, and I do not claim to know for sure anything at all, and so I'm not here to necessarily teach you things, or I'm not trying to cast this wide net to try to catch you know somebody interested in science or astronomy. No, I'm looking for my core group, the ones who want to come along, and this is not for everyone, right? It's just like a lot of other things, right? There uh, certain things um, people seem to gravitate towards for whatever reason, right? So yeah, I'm not trying to cast a wide net. as I said, I'm not trying, to teach anybody anything, or communicate anything at all. I just like uh, sharing this passion that I've had for really my entire life. I mean, uh, uh, I remember being very young, 5 or 6, and going into the local library and looking for the astronomy books. So even then, right? So that's just crazy, crazy. Um, Ever listen to the music on Soma FM? Huh, Bobby, I for some reason that name rings a bell, but I cannot connect to it. Yeah, for some reason that rings a bell, but so I'm gonna have to say no. I don't think I ever do. I don't think I ever do. So I've got the coffee here in the big thick mug. See that? Cheers. And and I do have the HOH tonight. Nice and relaxing. So cheers. Well, I'll tell you, Arizona is a desert, and by definitions, deserts are dry places. So, yeah, at my location, I want to say that we get like 12 inches of rain a year or so, something like that. And that varies, right? That's an average. So, some years we'll get, 6 or 8, and some years we'll get, you know, 20, 24. Um, 24 would be pretty unusual. Um, 16, 18, 20. Yeah, that would be those would be pretty wet years. So we've got this monsoon that always seems to start around the 4th of July or so. So I always say, the real fireworks start on the 4th of July. But this year, it has arrived on, um, well, at least my local date is June 29th, 2018. Now, of course, um, this live stream is is actually taking place on June 30th at 2:08 UTC. So 2:08 in the morning, Universal Time, on the 30th of June. So yeah, it's a weird thing being on a sphere, but oh, you'll get used to it. So what I wanted to say was, you know, if if you haven't subscribed yet, please do. You can hit the notifications. You can hit a thumbs up or a thumbs down, whichever you prefer. You can make some comments. I definitely like that. Anything, any kind of constructive criticism is extremely welcome. I mean, one of my things here is I want to get better and better and better, and and uh, and so and if you have to be a bit harsh, well, be a bit harsh. That's all right. I'm a big boy. I can handle things pretty well. Yeah, no, uh, it is very difficult for me to get um, offended. It's really hard. You have to try really hard because I'm I like the idea of diversity, and everybody has you know their own ideas, and I think that's great. I think it's great. They might all be different, but everybody's got them, and they hold on to them, and you know modify them as needed and all of that, and then we try to share these ideas, right? But your idea, right? Your idea is sort of contrary to mine. So it's like, you know, that's I guess that's a sense of tension, but I think that's great, right? I mean, there are two sides to a coin, so and there's an inside and an outside to everything. So yeah, yeah, I like it. So yeah, if there is any kind of criticism, um, lay it on, because that's how I get better. I can't possibly know everything. Um, so I'm doing this because it's fun, and because I think that there are quite a few people who sort of share uh, this this kind of passion, and that's a passion at all levels, right? I mean, I consider myself, sort of full spectrum, right? So in a lot of ways, I am a noob, like nobody's business, right? Don't have a clue. What are you talking about? I don't even know if I like this, all of that, right? And then I'm the amateur, right? Who likes to go out and just look around, right? Uh, uh, Grab the scope, some kind of event, right? An occultation, or some kind of an eclipse, or whatever it is, right? Yeah. I'll pull the scope out and look. You betcha. You bet, because that's fun, right? Um, um, Maybe you did, Bobby. I think that Soma FM rings a bell in my head, but I can't place it. So what I'm going to say in response to your question is, um, I don't think I ever listen to music on Soma FM. Um, but as I said, that name for some reason rings a bell. Um, but I can't place it. I can't place it. So yeah, uh, tell me more. Tell me more. More coffee. And then, right? So I've got this newbie attitude, I've got the amateur attitude, and I've got the pro attitude. Because I know what it takes to do, you know, the work necessary to you know, sort of analyze things in a scientific way. Um, do I follow particle physics? You know what? I don't. I don't. Not very much. Um, uh, yeah. The one thing that I've got to say about particle physics is actually very, very similar to what I say about astronomical things as well. And it's like, the harder we look, the more we look, the more we see, and the more we find. And I'm afraid that's happening in particle physics quite a bit, right? They're actually developing sort of this periodic table of elementary particles, and uh, they find little gaps, right? So they go look for things, that will fill that gap, and they find it. And is that something that they're doing, or is it actually there? I don't know. I don't know. Um, a lot of yeah. But yeah, to answer your question in a short way, the answer is no. I definitely do not. It's uh, you know, particle physics is definitely used in astronomy for sure. Um, but yeah, it's not anything that I follow or know a lot about. Not very much. Um, I'd like to know more, but there's only so much time, and yeah, yeah. So no, I haven't. I have not. All right, well, cool. So I got the ending done at the beginning, just in case I lose power. Now, the interesting thing right now is that it is pouring rain outside, but as you can see, the sun is shining. So that definitely makes this a monsoon storm. When the sun shines, when the sun is shining, and it's it's raining it's raining like crazy out there. And it's really pretty. It's really, really awesome. But yeah, that's monsoon. I don't know if you can hear it or not here. I don't know. Could you hear that? I don't know. Oh, cool. Cool, Otto. That's interesting to know. You're aware of archive.org then, yeah? I hope so because I think they have a particle physics section. Um, are you aware of this? Let's share and then hide. I'm pretty sure there's a particle physics section over at archive. Um, let's see. Where would it be? It's not condensed matter. Would you call that high energy physics? It's not really. Is it really high energy physics? I guess. Is particle physics high energy physics? Or is it like, no, it's not nuclear. I guess it'd be high energy physics. Does that make sense? Atta, you obviously should know. I don't see any other I don't see any other topic that's close to particle physics. Hey, well, I sold out of a degree altogether just to get a job, but it was the job of a lifetime. you cannot pass up obvious uh, once in a lifetime opportunities. So that was, and it just so happened that it was right in the middle of school. So it's like, bye. So is it? Okay, yeah, okay. So look, they've actually divided it up into four different sections. So phenomenology is probably the one, either that or experiment. I don't know what lattice is. I have no idea what lattice is. But anyway, Atta, if you don't know about this site, um, you will you'll go insane when you start reading all these things, um, because this is the latest and greatest stuff, right? New, right? This is the latest date up here, right? Uh, the papers on archive.org come out every weekday. So every weekday around 1 hour UTC or so, you'll get a new set of these. And there's usually 20 to 40 um, astronomical papers. I don't know how many there are for this particular topic, but sterile neutrinos with secret interactions. Dirac neutrinos with A4 flavor symmetry. Woo! I have absolutely no idea what that even means. Wow. So this is all from today, all these new papers today. Neutrino mass ordering in 2018, global status. The ordering of neutrino masses is a crucial input for a deep understanding of flavor physics and its determination, or yeah, and its determination may provide the key to establish the relationship among the lepton masses and mixings and their analogous properties in the quark sector. Yeah, it's a it's a Greek letter chi, so AR chi IV. So it's archive. Yeah, it's sort of a clearinghouse for preprints, is what they are. And Cornell is awesome, right? Is absolutely awesome. But you can see, they're sort of the last one. So there's quite a few new articles just in this section of particle physics. So yeah, check that out for all. I mean, it's an amazing place. Not only physics, right, but mathematics, computer science, biology, finance, stats, electrical engineering, economics. It's great. It's awesome. And rightly so, astrophysics is the first one. See, these people really know what is up, right? Astrophysics on the top, not mixed in with all the other rabble, right? Astronomy on the top, right where it should be. Yeah, Atta, just don't get lost in all those papers. You'll go crazy. Yeah, you'll go cuckoo in there. So be careful. It's it's 100 times worse than a candy store. Anyway, these are the astronomical ones that came out yesterday, right? Because we're into the weekend, so there are no updates. There won't be any more updates until Monday. Monday. What is that? Is that the first? I don't know. The second. The second. Yeah, there won't be anything until Monday the second now. So this was yesterday's uh, upload, and you know, as I say, these any any of these is worth taking a look, right? So read the titles, right? Read the titles, see if there's anything interesting there. Look at the authors' names. You know, sometimes the names are like, wow, that's a pretty interesting name. I wonder what they're doing. And then if all else fails, you know, look at the abstract there. You know, that's what these paragraphs are. It's like a executive summary of the entire paper in a very short thing. But yeah, so I was looking through these, and I really didn't see anything too well. Nothing jumped out. Nothing jumped out. I mean, it's all extremely interesting, but pulsar observations at millimeter wavelengths. That's pretty good. A panchromatic atlas of radio relic mergers. Merging cluster collaboration. Huh. Golovich et al. Presents an optical imaging and spectroscopic survey of 29 radio relic merging galaxy clusters. In this paper, we study this survey to identify substructure and quantify the dynamics of the mergers. Using a combined photometric and spectroscopic approach, we identify the minimum number of substructures in each system to describe the galaxy populations and estimate the line of sight velocity difference between likely merging subclusters. That's just amazing, amazing work. Wow. As I said, you know, any of these, you dive in, and then it's like a springboard to anything, you know. Well, you know, let's see if they've got any pictures, right? I that's my thing is look at the pictures. When you know, before we all could read and understand all those words, we looked at the pictures. So let's do that again. There's nothing wrong with that. This is either a really slow connection, or it's a really big file. I'll take another sip of this coffee here before it gets too cold. It's 70 pages long. Holy moly. How do I find these things? It's 70 pages long? My gosh. That's like a almost, it's not quite a novel. Wow. All right, well, let's just sort of page through this. And I mean, look how many authors there are. There's quite a few authors. But I cannot believe. Okay, so the merging cluster collaboration radio selected sample. So these are clusters of galaxies. Okay, they're talking about clusters, not individual galaxies, but clusters of galaxies. Auxiliary radio and X-ray data utilized in this paper. Oh, it's yeah, that's quite an amazing size for a paper. DS test for one RXS J0603. Well, it's a right ascension and a declination here. This is the beam size, so they're looking in the radio. Oh, and this is a measure of redshift. It's a measure of redshift. So the really blue is a a small red, well, small relatively speaking, and red is a larger redshift. The circles each correspond to spectroscopically confirmed cluster members and are colored according to their redshift. Oh, okay. Huh. I don't know. Can't say as I quite understand that. Yeah, I don't know what that one is either. It's a little bit of matrix algebra there. That's always fun. Table 3, priors for potential subclusters as deemed such by the routine discussed in section 4.3 for 29 merging clusters. The first two systems are presented here. The remaining 27 systems can be found online in a machine readable table. I don't know what all this means. I'm not even going to try. Subcluster measurement for the lowest BIC model. The dashed contours show the red sequence luminosity distribution starting at 3 sigma and increasing in units of sigma, where sigma is the standard deviation of the pixel value within R200. I'm not quite sure what that means either. So the dark lines are the radio observations, confirmed radio relic. The colored ellipses. See, there's a pink one and a blue, kind of a blue or violet one, an orange one, and here's a blue one here too. Show the most likely projected position and size of the corresponding Gaussians from the GMM. I don't know what that is. So X-ray, this is the X-ray image. I don't know. Okay, so they've overlaid the radio source. So you can see that, you know, for instance, this bright area in the radio doesn't correspond to anything in the X-ray. Right? The X-ray is over here. There's some correspondence here, right? Maybe. So yeah, it's hard to know what we're seeing there. It's difficult. Strongly lensed arc is apparent along several light peaks within the inner region of the overall light profile. Interesting. Yeah, wow, this just goes on and on and on. More pictures. Yeah, I don't know. That's beyond me. I could read it and probably pick up a little bit, but these are pretty extraordinary. I don't know if those are actual images or if those are let's see, the bottom left, 100 kiloparsec cutout of the Subaru Supreme Cam I-band image. Okay, so that's an actual image. I-band. So I think that's pretty into the infrared. Pretty sure. Yeah. It's as I said, sometimes I just like looking at the pictures and even if what I get out of it is like nothing to do with the paper itself, because I mean this is a pretty massive paper. Gee whiz! It looks like they just go through all of them here. All right, I'm seeing the same kind of thing, but look at all these. I mean, what's really amazing to me is all these are clusters of galaxies, right? These aren't star clusters, these are galaxy clusters. So that's pretty amazing. And some of these are small. Wow. These are really small. These are, yeah. What are they? 150? Okay, yeah, but on the sky, right, it's going from about 50 arc seconds up here to about, oh, 5. So I want to say 45, maybe 50 arc seconds on a side. Okay. Yeah, or 60, maybe. Yeah, I don't know. Oh, that's a 50. Yeah, I would think 50ish or so on a side. That's really small, right? That's an extremely small field of view. I mean, my field of view in my telescope is what, 12 arc minutes by 8. Uh, and we're talking about less than an arc minute squared here. Really, really, really small portion of the sky. Obviously, the instrumentation that took this is some kind of adaptive optics system. That's the only way I think that they can get things quite that sharp. So that's pretty extraordinary. Pretty cool though. But yeah, it looks like they just go through all of them. So yeah, all right. I'm gonna pass on that one. I didn't exactly pass, I guess. Swarm telescope concept. As I said, I really didn't see anything too interesting in here. This sort of caught my attention. Having thin, rotating spherical shells, but having waves that travel to the poles. I don't know how that happens. Apparently, it does. Yeah. See, as I said, I'm not seeing anything that sort of jumps out at me. Nothing too. Nothing too exciting. Quite a few papers, though, huh? Faint outburst of a pulsar. Identification and adaptive control of a high contrast focal plane wavefront correction system. Cool. And that's the end of that. That is the end of that. Well, you know what? Let's do a object of the day and then call it. Let's go with the NGC catalog again. So as you know, if you listen to this live stream enough, you'll know that there are 7,840 new general catalog objects. And most of them are non-stellar objects. So like galaxies, open clusters, globular clusters, planetary nebulae, and gaseous nebulae. Some of the NGC objects, though, are actually stars that were just misidentified, right? So you know, when they developed this catalog, they had a certain technology, right? And when they went to identify objects with this catalog, they identified a few stars as galaxies. So some of the NGC objects are actually stars. We came across one of those a couple months ago here, which was a total surprise because I thought they were all stars. Anyway, so let's see which ones we get. Now the order of the uh, these numbers is in the order of right ascension. So you know, NGC 1 is very near a right ascension of 0 hours, right? And NGC 7840 is very near 24 hours. So just by looking at the NGC number, you can you don't know where it is in terms of declination, right? The up and down part, you know, the north and south part, but you do know where it is east and west just by the number. So let's see what we get here. Drum roll, please. 2835. So 2835 is 36% of the way through the NGC catalog. So if I multiply that by 24, so the right ascension of this object should be around 8 hours, 40 minutes, something like that. Now there's a wide variation there. So, I mean, it'll be anywhere between, you know, 7 and maybe 10 or so. 2835. But let's see how close it is to actually 840. So let's go over to Simbad, my favorite astronomical database. And what was it? 2835. 2835. Probably a galaxy. Yeah, it's a galaxy. They're calling it an emission line galaxy.
I'm not quite sure what that means. Maybe we'll try to find out what an emission line galaxy is. But okay, well, that's not bad. 9 hours, 17 minutes. I I predicted from the NGC number that it'd be 8 hours, 40 minutes. So that's pretty close, right? That's within 37 minutes of arc. So that's not too bad. That's not too bad. Yeah, it's a pretty decent predictor. But as you can see, it's got a low declination. It's way below the, well, not way below, but it's 22 degrees below the celestial equator. 22, 21, 16. Let's see. So in right ascension, it's moving 1.13 milliarc seconds to the west, right? Because that's negative, and 0.063 milliarc seconds per year south. Whoop, where are we here? And it looks like it's moving away from us at 885. I hate that. 885.2 kilometers per second. So they're calling it a spiral BC. So yeah, it's a B spiral, which you can sort of tell from the picture already. Okay, it's definitely a spiral. It's got spiraled arms. Um, you know what? I'm going to correct myself. SBC, the B, the capital B means barred, and the C is a type C, which is pretty open arms, right? Very, very well defined arms. So that's a barred spiral galaxy, and you can see the bar, right? It's this structure right across here. So here are the magnitudes. That is how bright they are, or it is at different wavelengths, right? So B and R are in the visible. I don't know what G is. That's a new one for me. J, H, and K are in the infrared. So you can see that it's quite a bit brighter in the infrared. Um, uh, Brighter in the infrared than it is in the visible. Do you have it up on Discord yet, Uncle Bill? I keep every single time um, we do this, I uh, I think about it afterwards. It's like, man, I should, you're going to all that effort, to put it up on my Discord server, and I don't show it off. So I'm going to get over there and see if you've posted that already. So it's in Hydra. That's cool. I think Hydra was one of our constellations of the day, if I remember right. Let's see. Uncle Bill looks like he's on top of things. Oh, not yet. Not yet. Okay. We'll keep an eye out. Autos was the last comment here. So yeah, I'll let you do that, Uncle Bill. That'd be very cool. So, just as a reminder also, right, in astronomy, the magnitude scale is sort of reversed. So the smaller the yeah, the smaller the number, the brighter the object. So an 8.8 magnitude object is brighter than a 10.9, right? So it's sort of the opposite. It's sort of the inverse. The magnitude scale is based on a logarithmic scale. that uh, uh, happens to be a negative log. So that's why it's the smaller the number, the brighter the object. Yeah, it's just it's one of those things that we inherited from long ago, and yeah, I think if we could do that over, we would, because yeah, that's I mean, it's no big deal, but it's yeah, I think there are better ways of doing that. So like a small number for a faint star and a big number for a bright star. I Because then, I mean, what ends up happening, right, is that uh, what was done was a particular star was defined to have magnitude 0, right, and that star is Vega, right. Well, there are objects that are brighter than Vega. Okay. So where do you go from 0? Right. Well, the only thing that you can do is go negative. Right. So, and that's, I don't know. There's just big problems with that. We're stuck with it though. I don't really care what is used, just as long as everybody either understands it, and all agree to use it. Whatever it is, it's arbitrary anyway, so who cares? So here's a bunch of other names for this object, NGC 2835. Quite a few papers. That's cool. Let's see how far away, how fast it's moving. Okay, so they're saying like 8 or 9 million parsecs. So a parsec is 3.26 light years, and that's a mega parsec. And so let's multiply that by 8.5, because that's sort of right in the middle, times 8.5. Yeah, see, so that's only like 27 million light years away. That is really, really, really close. That is super close. But it's moving away from us at a pretty good clip, right? 880-ish, 890-ish kilometers per second. That's pretty impressive. Let's see, anything else here? I don't see any observations or anything. I wonder if let's go over to HST really quick and just see if there's anything there that's worth grabbing. Always like to grab free data. I mean, come on. It's better than free food. 2835. Name will resolve, and there are some observations from 1994 and 2011. Well, what do you know about that? Let's take a look, huh? Looks like they looked at it in 2 different wavelengths. Let's see what the images look like. Oh, that's pretty awesome. All right, let's do it. I'm game. 2835 201.jpg. Oh, let's just leave it. Okay, we got that one. Let's grab number 2 here. Same exposure time. So very, very blue and very, very red. 450 and 815. So we'll do this one. Well, where is he? There he is. Number 2. Okay, so number 1's the blue one, and number 2 is the red one. Thanks, Uncle Bill. We'll let's take a look while we're waiting here. Uncle Bill is so awesome. I don't know why it does that. So yeah, over in Hydra. So let's see. I keep meaning to do this every single time, Uncle Bill, and I don't. So okay, yeah. Here's Hydra. Yeah, it's a pretty bad time at the moment because the sun is right there, right? The sun is obviously, let's see, is this the yeah, this is the celestial equator. You're not showing the, oh yeah, there's the ecliptic. There's the ecliptic. So, oh, is this the sun? Is that the sun right there? That bright thing? I think so. So yeah, I mean it's right. It's right in the sun. So yeah, being able to see it now, no, you're not gonna. Definitely not gonna. Okay, is GIMP up? Come on, Gimpy Gimp. There we go. I hope this isn't too boring. Downloads, Astro. Okay, there they are. I gotta put you down. Hold on. Okay, they're loading. Thank you, Uncle Bill, for the screenshots. Okay, number 1, number 2. So I'm going to make this into an RGB image. Oh. Okay, now it's an RGB. Now I'm going to invert these. I'll invert this one. Oh. Okay, so now I'm going to come over here and I'm going to make this blue. Colorize it. Oh. That's a pretty nice blue. Colorize that. Let's make this screen. And we'll make this screen. And then we're going to make that one red. And let's just see. I mean, it'll look purpley, but that's okay. Pretty nice HST image. Kind of wanting to play with the colors a little bit though. So let's make this one blue and the other one red. Let's do that. So a nice blue here. That's a pretty decent blue. So make that one blue, right? There it is. And then we'll make this one red. See what that does. And then we'll go back. I'm not going to belabor this too long. Oh, we need to. Yeah, so I mean, that's sort of going to look about the same, I guess. Pretty cool though. Nice galaxy. Pretty nice galaxy, gotta say. But, we can make this any color we want, right? Let's do I'm just going to randomly pick one. Let's do that one, which is a blue. All right, let's not do a blue. Let's do that one. And that one. So sort of a pink and a lime green. That's not bad. Merge those things and play with the brightness and contrast a little bit. Yeah, I don't know. Pretty cool. Pretty cool. Okay, cool. Thank you for the clarification, Uncle Bill. All right, well anyway, there's that for what it's worth. Let's uh let's go back to the to this and let's look around a little bit. You can use Aladdin light. It's a very pretty galaxy. Let's look around, see if there's anything else really around. Just lots of foreground stars. There's a there's a background spiral over here. Looks like another one over here. But yeah, these are all stars in our galaxy. Foreground stars. Let's zoom out one more. We can see anything. Wow, there's just nothing. Just a bunch of stars. Cool. So yeah, that's a pretty nice looking galaxy though. Gotta say. Whoop, there we go. Gotta say, that's pretty nice. Almost, it looks like it's almost face on. It could be angled a little bit. You see how it's got this elliptical shape to it? That that tells me that maybe, it actually is a circle, but we're seeing it tilted, like, maybe 30 degrees, 45 degrees, something like that. So it's actually facing to our left. Does that make sense? If you draw, like a tangent line off of the center, it would be going off to our left. Um, but yeah, there's interesting structures in here. These are, I guess, like areas of star formation. These star form in these spiral arms where there's stuff, right? You got to have stuff in order to make stars. At least that's the theory. So, but interesting structures here. And, for sure, this side is very different than this side. There seems to be something funny going on here. But that's a beautiful bar. It's small. It's small. The Milky Way, our galaxy is thought to be a barred spiral galaxy. I think similar to this, pretty small bar, not very huge. Um, yeah, hard to take a picture of the outside of our galaxy from the inside. It's just it's it, it's I mean uh, I've always said, it's like taking a picture of the outside of your house from the inside. It just how do you do that? There are ways. There are ways. All right, well, cool. So let's go back. I sort of want to see if we can learn what a emission line galaxy is, because all galaxies have emission lines. Well, I'm not quite sure what that means. Let's just search for emission. H2O maser, a dihydrogen monoxide maser. Wow. X-ray emission from spiral galaxies with normal and low activity nuclei. And that's it. Monthly notices of the Royal Astronomical Society. Here we come. Go over to ADS. What do we got here? Guess we can grab it here. Let's see where this takes us. Oh, we got it. So what is it, 2835? Yeah. So let's just search for 2835. 2835. Oh, there we go. X-ray sample A. NGC 2835. There it is. Yay. Marked in blue there. I don't know what these numbers are. L might be luminosity. I'm not sure. But there's the one and only occurrence of that name in this paper. So let's see what these guys are talking about here. So the statistical analysis of the soft X-ray emission from spiral galaxies with normal and low luminosity active nuclei, derived from published observations obtained with the Einstein Observatory. I don't know if Einstein is still running or not. I think it might be. That was one of the first X-ray telescopes for astronomy that ever flew, I think. Has revealed a number of previously unrecognized characteristics of the X-ray emission. Seyfert 2 galaxies, the least powerful X-ray sources of the Seyfert class, turn out to be, on average, stronger X-ray emitters per unit light than non-Seyfert galaxies, whereas galaxies with liner nuclei and H2 region-like nuclei exhibit X-ray emissions of comparable strength. We verified that the X-ray luminosity is linked to the total hydrogen alpha emission line strength. Remarkably, more enhanced X-ray emission has been found in ARP Atlas galaxies, in galaxies included in the Atlas and catalog of interacting galaxies. Huh, okay. Well, that sounds very interesting, I guess. Kind of cool that 2835 was mentioned. Mentioned in one place, but that's cool. All right, well, awesome. I think let's go. Let's go back to Simbad here and just see if there's any other interesting papers. But I'm trying to be mindful of the time and seeing that we're starting to move into extended Astronomy Daily Live. Up to the top here. Isolated dwarf galaxies in a local supercluster. Yeah, I'm sure that galaxy we can see well enough to be able to pick out globular clusters in it. Very cool. All right. Well, you know what? I think it's time to go. I think it's time to exit this particular patch of planet. Yeah, I'm getting the call. I'm getting the call. So, all right, I'm going to get out of here for today. So, hope everybody does well. Just rewind this and watch what I said in the first 10 or 15 minutes. That is my exit for tonight. Just want to say, hold on to your hats because we're spinning really fast. We're not only spinning, but we're wobbling, right? And in fact, we're doing other kinds of motion as well, beyond the wobble. We'll have to look into that at some point. But for now, yeah, let's get out of here. Cheers, peace. Hold on to your hats. You're spinning fast. It's smooth, though. It's smooth. So don't worry too much. All right. Take care, everybody. I will see you in a little less than 23 hours. All right. Cool. Bye.